Hey everybody, so this is going to be solving right triangle applications. Basically what we're going to be doing is we're going to be going through word problems, and all the word problems are going to involve some kind of right triangle. And from the information given in the application or in the word problem, we're going to set up our triangle, and then we are going to solve for either a missing angle or a missing side or potentially everything in the triangle. But again, it depends on what the problem is asking us. We're going to use sine, cosine, and tangent here to solve for either our missing sides or our angles. So let's get going. So our first example we have, a tower casts a shadow that is 60 feet long when the angle of elevation of the sun is 65 degrees. Okay, how tall is the tower? So the first thing you want to do anytime you see an application problem is you want to draw the picture. Very few people can just be like, oh, I get this, let me just set up my equation and go, without drawing a picture, seeing what's going on, translating it into the triangle, and then solving it from there. So we have a tower. So this is going to be my version of a tower, which also might look like a tree, but oh, here's a window. That's a tower. A shadow that is 60 feet long. Okay. So the sun is somewhere in the sky, right? And it's casting a shadow, and this is the ground. So the sun is casting the shadow on the tower, and the shadow is 60 feet long. So this shadow is 60 feet. Oh, excuse me. That's not the shadow, because this is the shadow. I know how light works. The shadows be down here on the ground, right? So this shadow is 60 feet. When the angle of elevation of the sun is 65 degrees. So that means this angle here is 65, because the sun forms an angle, right, with the ground. So the angle of elevation from the ground to the sun is going to be 65 degrees. Our question here is, how tall is the tower? So as you can see, we have a triangle built. Right, the triangle is, here's the right angle. So we're looking at this triangle here, right, where this angle is 65 degrees. So the question is, so now if I take this triangle or this application, I'm like, okay, if I just look at this just as a right triangle, I know this angle is 65, and I know that this is 60. How tall is the tower? Means I'm trying to find this side here, so that's where I'm going to put my variable, and I'm just going to use x. Alright, well, how do I find x? Okay, well, what do I have? Well, I have an angle and I have a side. What relationship of these two sides to this angle do I have? Well, from the perspective of 65, I have an opposite side and I have an adjacent side. So which trig function should I use here if I have an opposite side and an adjacent side? So again, what trig function deals with opposite and adjacent? And I'm going to use one of the main three. Well, tangent does. So the tangent of 65 is equal to the opposite side, which is x, over the adjacent side, which is 60. And remember, everything is from the perspective of the 65. Okay, so I want to solve this. I want to solve it for x. So the first thing I want to do is get rid of the 60. So I'm going to multiply both sides by 60. And doing that, these 60s here knock each other out. So I get an x on the right. And then on the left, I get 60 times the tangent of 65, which we're going to throw that into a calculator, and we get 60 times tangent of 65. And I'm going to round it to one decimal place, so we'd have 128.7 feet. And so how should I answer my question? How tall is the tower? The tower is 128.7 feet. And there we go. Also, make sure when you're using the calculator, because we're measuring in degree, make sure your calculator is on degree. If your calculator is on radian, you're going to get an entirely different answer here. Our next example. So, Jackson is standing on top of a cliff that is 305 feet above the lake. Okay, so start kind of visualizing in your head what that looks like. The measurement of the angle of depression to a boat on the lake is 42 degrees. How far is the boat from the base of the cliff? So before we try to figure anything out, let's visualize what this says. So we have this cliff side here. We have Jackson who's standing here. So this is a cliff side. We're also going to assume here that this cliff is like a straight cliff. And then we got some water down here, right? Because here's a lake. And then there's a boat in the water. So here's a boat. And now what do we know? We know the cliff is 305 feet. What else do we know? The measurement of the angle of depression to the boat. So here, this line here, this is an angle of depression, right? Because we're going down. So this angle of depression here is 42 degrees. Okay. How far is the boat from the base of the cliff? So we don't know this distance here. This is what we're trying to figure out. That's what we don't know. So if I take that and I kind of make it into a triangle, right? I know that's 305. I know that's 42 degrees. And then what I don't know is I don't know this side down here. So what do I have again? So, and this is my right angle right here. This is a right angle here where the cliff meets the water. We're assuming is a straight up and down. So what do I have? I have an angle here, and with the angle, I have an opposite side of the angle and an adjacent side. So I'm dealing with an opposite and adjacent again. So I want to use the trig function that also deals in opposites and adjacents. And in this case, it's also going to be tangent. So tangent of 42 is equal to the opposite side over the adjacent side. And then we solve for x. So multiply everything by 305 to start. So we get x equals to 305 times tangent of 42. I'm going to also round this to one decimal place. So 305 times tangent of 42. And that'll get us 274.6 because I'm rounding to one decimal point. Okay, so what's the question asking? How far is the boat from the base of the cliff? The boat is 274.6 feet away from the cliff. Yay! Thank you, trigonometry. Okay, our last example that we're going to do. A 6-meter long ladder leans against a building. If the ladder makes an angle of 60 degrees with the ground, how far up the wall does the ladder reach? So question 1. Question 2, how far from the wall is the base of the ladder? Okay, so let's draw this situation. So we have a ground, right? Sounds like we have a building. And there's some windows in the building. Door that goes into the building. And there's a ladder that's leaning against the building. And this is the ladder here. The ladder is 6 meters long. Okay. This is a nicely built building, so it makes a 90-degree angle with the ground. The ladder makes a 60-degree angle with the ground. So this is the ladder, this is the ground, which means this angle here is 60 degrees. Okay. How far up the wall does the ladder reach? So that's asking for this side here. And how far from the wall is the base of the ladder? So how far is the wall from the base of the ladder? So that's one distance, that's one distance. In this particular case, we're going to solve for all of this. So what should I set up? Well, I have an angle, right? And I have a hypotenuse. So I have an angle and I have its hypotenuse. For x, x is going to be the opposite side. So I have an opposite and a hypotenuse. So I'm going to set up sine of 60 equals opposite over hypotenuse. And then for y, I'm going to set up cosine of 60. Why? Because I have an adjacent side and a hypotenuse. So I'm also going to set up cosine of 60 equals the adjacent side, which is y, because that's the side that's touching, over the hypotenuse. Okay, I can kind of solve these simultaneously. The first thing I'm going to do for both of these is multiply by 6, because they're almost the same problem. And then I get 6 times sine of 60, that will give me x, and I will get 6 times cosine of 60, that'll give me the side y. So x is equal to 6 times sine of 60 times 6, and I'm going to round to 1 decimal place, 5.2. Now what are my units? I'm using meters. Okay, now 6 times cosine of 60 is 3, because cosine of 60 is 1/2. And then 3 meters is equal to y. So to answer these questions, the ladder goes, for x, the ladder is 5.2 meters up the wall, and the wall to the base of the ladder is 3 meters. Okay, so this was wall to base of ladder, this was height up the wall, right? How do I know that? Because x is what I solved for, and x was this distance here. How do I know this? Because y is what I solved for, and y is this distance here. So if you have any questions, please, please, please don't ever hesitate to ask. I hope that cleared some things up for you guys as far as about how to solve these word problems. Step 1, draw your picture, so visualize what it is that they're saying for you. And then after that, pick out, be like, oh, there's my triangle, and identify what you know and what you don't know and what you're trying to find. And then identify what trig function you should use based on the information you have. Do you have an opposite and a hypotenuse? Then use sine. Do you have an adjacent and a hypotenuse? Then use cosine. Do you have an opposite and adjacent? Then use tangent. And those are the only situations you're ever going to be in, because that's all combinations of the other two sides. Okay. So I hope you enjoyed this video, and I will see you guys in the next one.